Today we are going to revise chapter gravitation. The first question is state the universal law of gravitation and name the scientist who gave the law. According to this universal law of gravitation, every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. English scientist Isaac Newton gave this law. The second question is, what do you understand by universal gravitational constant G? According to Newton's universal law of gravitation, the force of attraction F between the two bodies of masses m1 and m2 separated by a distance r is given by F equals to G m1 m2 upon r square, where G is called universal gravitational constant. Its value does not depend on the medium between the two bodies. That means the bodies may be terrestrial or celestial, or the masses of the bodies, or the distance between them. The value of G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. That means it is too small. Now SI unit of G, capital G. Now G can be written as F into r square upon m1 m2. By substituting the values of SI units of all these quantities here, we are getting SI unit of G equals to Newton for force, for our r square, that means the distance, it is meter square, for m1 and m2 masses, it is kg square, so it will become Newton meter square per kg square. The gravitational force between two bodies does not depend on their separation, that means the distance, their masses, the product of their masses, and D, the medium between the two bodies. So here option D is the correct answer, the medium between the two bodies. That is why it is called universal law of gravitation. The gravitational force between two bodies or objects is F. If masses of both objects are halved without changing distance between them, then the gravitational force would become. Here are four options. Now we have to find out the actual answer. Initially, let the masses of two objects be m1 and m2 separated by the distance r. Then the gravitational force between them will be F equals to capital G m1 m2 upon r square. Now when m1 becomes m1 upon 2 and m2 becomes m2 upon 2, then the gravitational force between them will be a new force, and if we denote by f dash, it will be equal to f dash equal to G into m1 upon m2 into m2 upon 2 whole upon r square, which gives us f dash equals to G into m1 m2 upon 4r square. Now here by rearranging we can write f dash equals to 1 upon 4 bracket G m1 m2 upon r square. This is the value of f. So f dash equals to 1 upon 4f. That means the new gravitational force will become 1/4 of the previous one. The next question, the value of constant G in the law of gravitation depends on mass of earth only, depends on radius of earth only, depends on both mass and radius of earth, and the last one is independent of mass and radius of earth. So as we have discussed earlier, it is independent of mass and radius of earth. Now what do you understand by free fall of an object? The falling of an object from a height towards the earth under the gravitational force of earth with no other forces acting on it is called free fall. Question number 7. Define acceleration due to gravity. Give an expression for acceleration due to gravity in terms of mass of earth, capital M, and universal constant, gravitational constant G. The acceleration produced in the motion of a body falling under the force of gravity is called the acceleration due to gravity. It is denoted by small g, and small g equals to capital G m upon r square, where m is mass of earth and r is radius of earth. We can see from this formula that the value of g is maximum at the poles, but because the distance of the pole from the center of earth is minimum, and the distance on the surface of the thing of the earth from the center of the earth is maximum. So the value of g is maximum at the poles and minimum at the equator. The gravitational force of attraction between two objects is x. Keeping the masses of the objects unchanged, if the distance between the objects is halved, what will be the magnitude of gravitational force between them will become? Initially, x, the gravitational force between the two objects, x will be given by g m1 m2 upon r square, where m1 m2 masses of the objects. When the distance between the objects, that is r, is halved, then new force of gravitation will become x dash equals to g m1 m2 upon r2 whole r upon 2 whole square, which gives us x dash equals to 4 into capital G m1 m2 upon r square. Now here this value is equal to the previous value, that is x, so we can write it as x dash equals to 4x. That means the force of gravitation will increase 4 times.